daily operation is basically the core story I would like to bring today. When we discuss electrification, policy support is often viewed mainly from the government perspective, while from an operator's perspective, the key question is how policy priorities evolve with the maturity of deployment, and how operators like us respond at each stage. Among the broader new EV policy categories, we think 3 types were particularly relevant to operators, including vehicle purchase subsidies, charging infrastructure support, and performance-linked regulations. As you see in the early stage, the broad subsidies did help to reduce the high upfront cost of electric buses and enable the large-scale fleet replacement. In the mid-age, our policy focus shifted toward technical standards and subsidy eligibility. That means operators had to select compliant vehicle models to strengthen technical planning and to use operational data to support fleet and infrastructure decisions. And today, in the current stage, our policy has moved further toward performance, quality, and efficiency. For operators, electrification is now increasingly about scheduling, digital tools, service reliability, energy efficiency, and passenger experience. So the key message here is that electrification policy and planning should not remain static. It needs to evolve with the local deployment stage and industry maturity. So charging is the key topic of the electrification. So it's also one, we think, practical example of how electrification structure had to be adapted to daily operations. At first, charging could be seen mainly as an infrastructure task. But at scale, it quickly became an operational coordination challenge for us. We faced a lot of issues such as limited depot space, insufficient charging plugs, long charging time of use electricity pricing, etc. So our charging approach evolved from a basic charging arrangement to more integrated operational planning. So at the route level, we considered the route length, trip frequency, daily mileage, energy consumption patterns, peak-off-peak service windows. And for the vehicle, at the vehicle level, we consider a series of other input like operation hours, shift arrangements, SOC, electric pricing windows, and those help to improve the alignment between the charging plans and our service timetables, and increase our charger utilization to reduce our vehicle queue and idle time, and of course, lower our electricity cost. So for us, the lesson here is very clear. Electrification infrastructure should be planned and upgraded based on the real operational constraints and the service needs. So as our electrification matured, now our focus expanded from infrastructure coordination to intelligent operations. But as we know, digital systems only create value when they are integrated into daily operation management. So our intelligent operation framework covers several areas. As you see here, smart onboard system like ADS to support our safer driving and risk prevention, the digital dispatching and the passenger information system to improve our transparency, predictability, and passenger experience, data-driven network optimization to support our route planning and operational decisions. And of course, the workforce support, which includes the pre-shift checking system and employee assistance program to help support our driver well-being and operational resilience. So for us, intelligent operations are not only about deploying kind of a technology in the activities, they require continuous coordination between the different systems, the frontline operations, and the people. So our OD analytics system is a good example of how operational reality has shaped the digital development. In Shenzhen, our local context is a bit different. We only have the tap-on system. That means with the payment data, we don't know where exactly our client, our passengers will alight. But another important context is that in Shenzhen, we have some flexibility to design our bus size, our service frequency, to change some route structure and the actual demand. So that creates a strong need for us to for more accurate passenger flow analysis. Then during the system development process, we actually continuously to provide the operational feedback to our technology partners that led to a sort of a head, shoulder, neck recognition algorithm which can match boarding and alighting information anonymously without capturing the facial identity. So to conclude, here are the 3 lessons I would like to bring actually to share with you here. So first is for electrification, we need to plan by phase and adapt to reality. We know the policies and infrastructure planning should evolve together with electrification maturity and operational needs. Second, for digitalization, we need to let the operations shape the system, and digital tools create greatest value only when they are embedded into real workflows and to support by the operational flexibility. Then third is that we need to build our capability for long-term impact. Because we know transformation not only depends on technologies, it also depends on workforce readiness, operational capability, and our employee well-being. So overall, large-scale transformation is not achieved through a single technology or a single project. It's a continuous process of operational integration, adaptation, and coordination. Thank you for your attention. And on these final slides, if you need more information, I recommend you scan the QR code. You will have you can download a case study report we jointly created with World Bank about the story of Shenzhen bus electrification. And you have a short video about our activity. And more importantly, there is a program of training if you are interested in, which cover e-bus operation, autonomous technology, which will be held October this year in Shenzhen, jointly by Shenzhen Bus Group and UITP. You're welcome to Shenzhen. Thank you again.
Thank you, Mr. Ma. Please stay on. So let's open the floor for any questions from the floor, please. Yes.
Thank you. Good morning. Thank you for your inspiring presentation. I would like to ask one question. As we know that the infrastructure and collaboration between other transport modes also important within the ecosystem of the transportation. I would like to ask your opinion, how you see this collaboration with the other modes of Shenzhen bus, especially with the railway ecosystem, since I am from MRT Jakarta. Thank you very much.
Thank you. That's a very good question.
Thank you for your question. We know recently MRT Jakarta just came to Shenzhen and we signed a memorandum of understanding with Shenzhen Metro. Actually, I think this is mostly the thought or the job we are working with our transport authority because we are only the bus operator. What we do is mainly to focus on the infrastructure, the planning, the service, and the optimization under our portfolio. While Shenzhen Metro, what we do jointly is the most key point is how to optimize the feeder service. I mean, in the same time, with the expansion of the metro network in Shenzhen, for example, we kept downsizing our bus fleet in the recent years and shortened some length of the bus routes. Now reorganize our bus networks with the support of the OD system. But in the same time, we also have the continuous exchange of data at the public authority level from both our OD system and the EFC system from Shenzhen Bus Group to know exactly where the passenger go and come from A to Z during the whole day, in order to better organize or propose the feeder service between the trunk transport means, I mean metro, for example, and bus services. So that's something we kept doing for a long time. That means the feeder service. The second is that we, as a bus operator, we are now expanding our service from the regular franchised bus service to some on-demand service to the areas where the metro system will never reach. We are not well served yet by the franchise services either. So that's we call ODT service, ODT bus service. Now our ODT market, I mean the revenue compared to our total bus revenue is already representing 20%. That's something huge, I think, compared to other bus operators. That's something I think we, as the different modes of transport, what we can do together, what we can coordinate to integrately improve the overall efficiency of the public transport system.
Thank you so much. I think there are a lot of things that can be learned from Shenzhen Bus, the experience, operational experience, and then the policy setting, etc. So maybe I hope there are opportunities among the countries or private sectors with your company to share the knowledge going forward. Thank you so much.
Thank you.
Now, our next speaker is Mr. Adrian Simmons, a senior transport specialist from ADB. He has extensive experience in maritime transport, ports, and logistics. Please welcome Adrian.
Good morning. Доброе утро in Russian. Good morning. We're going to move modes now from rail, from land-based transport systems, rail and road, and we're going to jump into the water. So this is waterborne transport. Thank you for the introduction, colleagues, distinguished guests. So first I'd like to just quickly acknowledge support from some sector groups that have allowed me to develop this technical assistance project, which is now coming to fruition. So thank you for the Central West Regional Department and the funding capability from the CSPPF. And also to support and from friends Jürgen Schlurter, Ari Kalikowski, and Masa Nishimura, so to recognize their effort. It's a team effort and an important one for the CARAC development. So the context, we're developing we're transacting the technical assistance activity, which centers upon a CARAC Corridor 2, or the Middle Corridor as it's known. So why does this matter? So in ADB and the member countries, we spent last decades heavily investing in rail corridors and road, and rightly so. But what we're now seeing very clearly is that corridor performance is no longer singly determined by the land transport. Increasingly, it's defined by the connectivity with ports, shipping services and logistics services, and multimodal connectivity and the efficiency of those. So for landlocked countries, and we heard from Uzbekistan, one of the few double landlocked countries, that port rail interface is now a critical constraint. The process that we're engaged in is updating a study on ports and shipping and intermodal connectivity that was published in 2021, but using baseline data from 2017, 18, and 19. And a lot has changed since then. So this study will be using that as a baseline, but the shifts have included changes to trade flows, and as we've seen, there's geopolitics in the world have created stresses for global trade and global delivery and global shipping, which have meant that other trade corridors have elevated a certain level of importance relative to their capacity that can take some of the volume from some of the constrained trade routes. So corridors have been rerouted, trade's been rerouted, climate risks have intensified, particularly in the Caspian Sea basin. Infrastructure's aging and under pressure, and critically the ports, shipping, waterborne transport logistics systems are not keeping pace with the rail investments. So the bottom line, and the reason that we're progressing with this TA is to focus on the the multimodal bottlenecks and how those constraints can be unlocked to improve the CARAC corridor performance overall. So strategic framing, this matters on the Trans-Caspian Corridor, also referred to as Middle Corridor or Corridor 2. And the performance is still considered constrained by port inefficiencies, limited shipping capacity and reliability, weather-affected shipping patterns, weak integration with the rail systems, and fragmented institutional arrangements. So the issue is not infrastructure alone, it's a system-wide performance across the multimodal chain. What the TA does, so the core message is that the technical assistance is designed to address that it's not just another study, it's a pipeline building, so it's an investment-focused, investment-oriented technical assistance piece of work. So the starting point is updating the baseline that was produced from the 2021 report, focusing on the ports, the shipping systems, logistics corridor, and the corridor performance, and then reflecting on what happened since 2021 relative to trade shifts, global patterns, climate impacts, and new operational constraints, and the improvements of capacity with the land-based transports, with rail in particular, and also road. And secondly, to diagnose those risks and those constraints, particularly when it comes to climate vulnerability, Caspian Sea water level variability. And we hear often that climate change is causing sea level rise. In the Caspian, it's the reverse. The water depth is decreasing. Extreme weather exposure to shipping and port activity and infrastructure capacity constraints and institutional and coordination gaps. Some photos that I'm responsible for, as well as some others that others provided. So the solutions, so it's the implementation and the interventions are not just in theory, and ADB has a wealth of knowledge relative to the development arrangements for ports and shipping, and the interoperability and the connectivity efficiency between ports, shipping, and land-based transport. We've also incorporated into this new TA green port development, electrification, shore power, which is providing power from the port to the vessels whilst they're operating at berth so they can switch off their generators, operational efficiency of cargo exchanges, decarbonisation pathways, digitalisation of port systems to help with the integration and the connectivity between the port, the efficiency within the port, and the connectivity between the land-based systems. The investment pipeline translated to the prioritised and bankable projects will be the ultimate outcome of this TA, and the focus will be the beyond just modal thinking. It'll be a complete system-wide network focus, incorporating rail, road, ports, shipping, and the logistics systems. The interdependent components of that will be looking at planning and the governance, and then the financing pathways for those developments. So to close and conclude today, we have a strong baseline from the 2021 CARAC Ports and Shipping Study, and I'm wrapping up rapidly. I've got the notice, and we also have a shifting operational environment with further pressures introduced from global conflicts that have rerouted trade and put pressure on other systems and other trade routes and the capacities which they can currently handle. So the TA is also, the technical assistance also designed to strengthen climate resilience within the ports and shipping network across Corridor 2, the Middle Corridor, which incorporates the Caspian Sea and the Black Sea, and support the development of a real investment pipeline So for Carrack and the middle, and particularly the middle corridor, it's not optional. This is a fundamental a focus on the future competitiveness and the resilience of waterborne transport in the Carrack realm. So thank you very much.
Oh, thank you. Thank you, Udiro. Please stay there. And so we'll get one question from the floor due to the time constraint. Please. There's none, then may I?
Please.
Oh, so I think there are many different interventions or mechanisms that that would ensure the short-term, the nearest and biggest benefits or gain by improving the network or the port. So if you can pinpoint one intervention out of many, all those are very much connected. What that could be?
This is sort of a one-word answer, I think, which is digital support systems, so digitalization and the application of digital systems to improve the efficiency. And we're dealing with any form of transport and listening very closely to our colleague Ma Yi from Shenzhen Bus. It's the same principles, the same protocols apply. So headway, transit times, frequency, all relate in a transport realm when you're delivering freight as a unit cost. So dollars per ton per mile on a time scale. So if you're within the threshold of delivering within your anticipated transit and frequency times, then the traders, those paying for the freight to move between A and B, then they can do business rationally and focused, and the system works, and the transactions and the economy grows in accordance with that. If there's failure in the system, then of course you have increases in the delivered cost. The dollars per ton go up, which impacts economic growth, and the financing then becomes weaker, and the opportunities become weaker. This is particularly important in the Central Asian realm, where landlocked countries and countries with near ocean rely extremely heavily on the efficiency of trade and the interconnectability between the two. And so digitalization, digital systems can help connect between those two and create some reliability within the system. It's using those systems appropriately. Yeah.
Yeah, that's a great answer, and I think we can have a whole day training or workshop with that digital solution for the maritime transport. Thank you so much, Adrian. Okay, now we welcome Mr. Robin Workman, an international consultant specializing in road asset management and maintenance in low and middle income countries. His presentation will describe efforts in Nepal to strengthen climate resilient road asset management and build institutional capacity for more sustainable infrastructure management. Thank you.
Thank you. Thank you. So, I'm going to present the rural connectivity improvement project in Nepal. At the moment, we're doing with our local partners, Scott Wilson, Nepal. So, the project itself is supporting upgrading of rural roads in Nepal in 5 provinces out of the 7. Nepal went through a process of federalization a few years ago, so the provinces actually have a lot of autonomy to design and develop their own roads and use whatever standards they feel appropriate. So there's quite a lot of autonomy for them to do that. The project focuses on the 3 main aspects: asset management, climate resilient design, and road safety, and as well, of course, the institutional capacity building that goes along with that. Our initial sort of situation analysis defined that there's a lack of knowledge and data on asset management, and that performance-based contracts which were being implemented on the upgraded roads after the defects liability period for 2 years were actually not implemented in a very efficient way. There's some misunderstanding by contractors, etc. So we looked at that. The standards and guidance available to the provinces don't consider climate change. There's a general lack of capacity and no real sort of strategy to address that. So I'll deal with those three main aspects of the project, starting with asset management. So to start with, we did a maturity assessment based on the IIMM process. So you can see that there's various aspects you look at individually based on a sort of traffic light scoring process. So all of the provinces were either basic or aware. So the capacity was very low. That's not a criticism. I mean, there's no asset management system available in Nepal, so we're really starting from quite a low base. We also did a training needs assessment, so that allowed us to then develop an institutional framework for progressing. Basically, the coordinating agency, DOLID, and Department of Local Infrastructure Development, and then the provinces, we agreed with them what their individual responsibilities were as a framework for sort of moving forwards. And then that led into the roadmap that you can see down here. And we envisaged a sort of a 5 to 10 year timescale for implementing asset management properly into Nepal, given the quite low base that we were starting with. And the provinces even have to develop their own roads acts and provincial transport master plans, etc. So there was quite a lot to do there. The performance-based maintenance contracts that were ongoing, we had a workshop. My colleague Colin Broadwood here managed a workshop to define what the problems were. And actually the knowledge of maintenance, etc., was very good. And they were using an ADB contractor, which again was good and had been revised appropriately, but it was just the process that needed to be improved. So we drew on the CAREC, ADB CAREC experience on PBMCs, which was very useful. We developed some guidance specifically for Nepal, and we undertook some training in all the provinces centrally and had a study tour to try and raise awareness on these. And the recommendation was that we would, that the provinces would roll out second generation performance-based maintenance contracts. So broadening the PBMCs across a wider range of roads, not just to roads that have been rehabilitated, but also to old roads with potholes, with cracks, so that the contractors could invest and actually engage more on a longer time period, so 5 to 7 years, rather than just the 2 years that the trials were being done in. So that's how we promoted the performance-based maintenance contracts to progress there. And then climate change. We've heard in a couple of other presentations this week about the environment in Nepal. It's very fragile, very erodible, and so climate has a big impact. So we started by reviewing the designs of the upgrading roads to see where they could be improved. We revised some of the standards available to the provinces. So there is a rural road design standard, but they tended to use the higher level standards because the roads have sort of progressed away from sort of labour-based construction towards more the construction. So we moved on to there. There's bioengineering, a big thing in Nepal. So there's some bioengineering manuals that were produced in Nepal, which are very widely used, very well respected, and they are now being upgraded after 25 years. And we've got the original designer for those manuals to come back and upgrade those for, again, a wider range of environments, and to also include nature-based solutions. So you can see we used this guidance there, which was developed under a different project by TRL, just to incorporate that into the bioengineering guidance as well. We also produced a sustainability plan framework for the provinces to allow them to to screen their roads for climate risk, etc., and undertook sort of extensive training across Nepal at all levels and things. So the project finishes next month. We're looking forward to finishing that off and hoping that it'll come to fruition, and that Dolid and the provinces will increase their sustainability in the future. Thank you.
Thank you, Robin. So again, let's open the floor for any question. I think we can have some, please. Anybody? Okay.
Thank you very much for the presentation. My name is Desi from MRT Jakarta, Indonesia. I think just one quick question. How you monitor the asset condition in the asset management for taking action to the maintenance or repairing the asset? Thank you.
So that was how we monitor the condition of the roads. Well, at the moment, it's not monitored. There's no condition assessment that goes on, but we've looked at how we could do this sort of sustainably for Nepal. There is a contractor at the moment who's helping them develop their provincial transport master plans, and obviously for that we need condition data of the roads to understand how they deteriorate and what their condition is. So they have an in-house system developed in Nepal, and they're monitoring roughness, and they use videos to actually assess the condition of roads automatically. So that's what we're trialing at the moment, but there's so many different options for data collection at the moment, especially AI-generated options. So I think that's something that we need to keep in mind, and perhaps transition towards that when it's proven and actually more commercially available.
Thank you. And if I may, so there was a session earlier regarding the use of AI technology and monitoring the road conditions, etc., so that we can revisit the YouTube on that session, so you can have some insights from that. My question is, what does the data say about the life cycle cost of resilient design versus reactive repair?
Yeah, thanks. So, I mean, given the status of asset management in Nepal, we don't really have any data to go on. But I think in terms of climate design, and especially in a country, Nepal, where connectivity is so important, and so many poor areas in remote areas which are very difficult to get to, I think it's about building the resilience into those standards and demonstrating that the value of actually having a resilient design as opposed to traditional designs. I mean, there was a move in Nepal to lots of the districts used to just hire bulldozers and just make roads just to get connectivity, and within 2 or 3 years those roads were just gone. So it was sort of a fairly blatant waste of money, and that's practice seems to sort of change now, and I think that was through the demonstration of that just doing connectivity without awareness didn't work.
Okay, so the authorities, I think they have now, well, going forward, increased awareness of having the climate resilient design, and we hope that trend can keep up going forward. Yeah, thank you.
Thank you.
Now I would like to give the floor to Sophia Moore, Associate Principal at ARUP and Planning Practice Leader for Asia Pacific, who has worked extensively on large-scale master planning and land use and transport strategies across Indonesia and the region. Her presentation explores how mobility systems can be reimagined by reconsidering who needs to move, how they move, and the wider social, economic, and community value that mobility infrastructure can create. Thank you.
Yeah, thank you so much for the introduction and the opportunity to reflect on our practices at ARUP and how we can contribute to this conversation. I wanted to share some project examples from Arup where we're thinking about mobility in a greater context of place and how we need to think about that place context to deliver greater value from our infrastructure and mobility investments. I wanted to first start with this image. It's an image from the Centre for Science and Research in Australia, and it's a piece of infrastructure that suggests that it can harness energy from engagement from the community in their love of wombats. And this is a really cute piece of infrastructure, but unfortunately it's not real. It was an April Fool's joke. But I thought it was a really interesting image to help question and explore what infrastructure means in our cities and how we might look at infrastructure in terms of its role in engagement in place and how it needs to contribute more to community and nature. And this is something that we've been talking and thinking about in Arup for some time, recognizing that we need to think about infrastructure in this broader context of place because there are so many constraints around urban environments. We know that there's a really large infrastructure gap, the fiscal capacity of governments is really constrained, and there are multiple challenges and opportunities within cities. So we can't just take a linear approach to infrastructure investment. We need to look at infrastructure about in this kind of equation, going from 1 + 1 = 5, this kind of multiplier effect, being able to deliver on multiple challenges, to bring balance of impact across social, economic, and nature components, to deliver impact beyond just a site or a linear piece of infrastructure, to catalyze further investment from the private sector, and to engage multiple stakeholders so those stakeholders can also get benefit. So I wanted to share two examples from Arup where we've taken this broader place-based approach to infrastructure. The first is around designing for the nighttime. This is an approach that we've been taking with our colleagues from the lighting team, transport team, urban planners, urban designers, and our risk teams. And it's an approach where we recognize that actually nighttime's not really considered in a lot of urban development and infrastructure design. And that's a really big missed opportunity in terms of economic development and something that we need to readdress. So we have both a technical kind of assessment process as well as a process to engage the community around a greater understanding of the perceptions of safety and activation. We've applied this approach through a series of projects, and one was a UK government grant project in Semarang. It was a project to enable greater access to low carbon mobility for vulnerable communities. And we looked and targeted a specific location, the old city in Semarang, recognizing that there was already some existing public transport infrastructure, rail and bus, but it wasn't very connected, well connected to this really strong cultural asset in the city. So we undertook some assessment. We did that technical assessment with our lighting team, as well as a night walk with the community, with representatives from the Disabled Groups Association, the women's groups, and other NGOs within Semarang. And it was a really important understanding of place. You can see these layers of experience of the city, recognizing that infrastructure and that lighting component, that hard infrastructure, is only some components of what we need to get right in cities. We need to layer that infrastructure together with this broader coming together of activation and space and a variety of users to come together to make our cities feel comfortable, safe, and attractive. Through that work, we had some recommendations around lighting, recognizing that we can't just come in with brightness alone. We need to think about quality. We need to think about the layering of some of that lighting design to enhance wayfinding. And I think this third point is really interesting around connecting to the other parts of the city. So there's the infrastructure component, but the informal components of the city around the street vendors, they were really important safety assets in the city, and something that the lighting component shouldn't displace or replace, but to complement. This is some really interesting work that we did and contributed to the greater conversation around infrastructure and place. The second example that I wanted to share was around some work that we're currently doing, also in Indonesia, around transit corridor planning. And this is some current analysis we're doing to really understand the place across different layers, but through open source data, recognizing that we sometimes work in really data limited contexts, and the need to engage with data quickly and cheaply is really important. So we're looking at a corridor-wide understanding of the bus rapid transit being implemented in the Bandung metropolitan area. It's about looking at a corridor approach, so we understand the centres working in complementarity, not competing. And we're also looking at the first and last mile elements of connecting these transit-oriented developments to the broader context. So we've been able to look at different open source data to build up a multi-layered understanding of place around population density, land use, road characteristics, traffic volume, sidewalk widths. We've done some observations as well around street vendors and helped us understand TOD clusters. The other component that we've looked at is extracting this point of interest data from Google Maps. So this was data that we did pay for, a very small amount, I think only 200 Australian dollars. And we extracted the Google review data, and where we saw high numbers of reviews, we recognized that they were really important attractors in the context of the city. And so that helped us identify strong points of attraction that could act as strong centers in that TOD network. There was also data around the building footprints. So we were then layering the point of attractions to those areas that had larger footprints and spaces overall. So there might be large landowners that we could then engage with and talk about co-investment of some of the bus infrastructure, say, for example, bus stops within those centres. So these were helping us understand this corridor further to then prioritise the specific locations of the centres. So these were just two examples that I wanted to share from Arab to help showcase how we think about this place-based approach to infrastructure, and welcome any conversation and questions. Thank you.
Yes. Can anybody pass on the mic?
Thank you. Ivan here from Alt Mobility PH. So my question is, where do you get your open source data?
I believe it was from Google, the open source data from their various transport layers of the city that were available.
Do you use like other public data, like other than Google?
I think there was some citywide data available, but we were relying on more of the public open source data to help us have that enriched data source and understanding of the corridor. Thank you.
Thank you, Sophia. That was very insightful presentation. I'm kind of impressed about the layered lightning for the unofficial community economies. Thank you so much.
Thank you.
Now we move on to the next speaker, Professor Filippo Giuttazzi from RMIT University, a specialist in pavement materials and sustainable transport and infrastructure. He will discuss the use of recycled and sustainable materials in road construction, particularly in developing countries, remote communities, and how local waste streams can support more sustainable infrastructure solutions. Thank you.
Thank you. And good afternoon, everyone. I think it just passed me day. So my presentation today is about how we can reuse our waste better. The whole session is about from ideas to impact. So I will probably show you some of the ideas that have been translated to impacts not just in Australia, but in the previous session I was talking about how we changed a little bit of this environment in Papua New Guinea, but also all around the world. So if you are a developing country, especially a Pacific island, you might have seen your waste growing over the past years. Not just construction waste, but you can see there is paper, there is cardboard, there is tires, there is plastic, there is forestry type of waste, and so on and so forth. So the idea is that if we can take that back or some of it back and re-engineer it, we might be better off in the long term. Now, I've just put here 3 of the mainstreams. In Australia, for instance, construction and demolition is the mainstream when it comes to waste, but other countries might have plastics or a different breakdown. Vehicle tires is one that is very important, and there is not enough consideration given to it, I think. But the main idea and the main message that I would like to convey is that we don't take the waste and we just reuse it as it is for road construction purposes. It needs to be recycled, it needs to be processed, it needs to be engineered. So we are not just shoveling waste into the roads, into new roads, but we are re-engineering it, and then eventually it gets into the road. As a performance enhancer, most of the time, in a minority of other scenarios, it can be used as a inert filler, like recycled aggregates from construction and demolitions. This is just for you to see that that's the city of Sydney on the left-hand side, and if we put together all the vehicle tires that have been produced in New South Wales in a year, you basically can cover the entire skyline of Sydney. So it's quite a significant issue. Not many people know that when you look at what's inside your vehicle tires, you can find rubber, number 1 up there, but there is also steel, there is a textile, and there are other additives. Now, the steel is always taken care of because it's the easiest to recycle. Textile, still very difficult, it's very fluffy and high volume. But the rubber, number 1, is what we're interested in. It's something that can be reused with value. And that's what we've been using in Australia for many of the roads there, but all around the world. This is not a new technology, just something that can be implemented quite easily. Now, this is an example of a mining site. Not many people think about this, but mining tires are very big, and you can see examples up there. And what usually happens to these mining tires is that the mining site, they dig a big hole, they put all the mining tires in there, they cover the hole. And that's 99% of the cases. We found from the idea that we had to an impact, we found that this can be recycled as well. And we partner with the local industry to find a solution for it. And after separating, you can see the steel in the middle section there, you can get the crumb rubber eventually at the end of it. So it can be reused in bitumen and to make roads and to make better roads. The same can be done with plastic. As I said, I've just delivered a presentation in the other room explaining how we started from an idea in Papua New Guinea where people were just scratching their head, not really knowing much about it, and now there is a group of more than 50 people that is separating plastic, using plastic, and building roads with plastic. That's just an example. It doesn't look any different, so do not expect to see shiny colors because we're using recycled plastic. If the right source is selected, it's engineered, the road looks exactly the same. Recycled waste can be crushed and reused as a sand for construction, especially in places or countries where there is a shortage of raw material, then this can come in handy. Recently, there has been a big shift into the bio-resources. So everything that is a biomass that can be reused coming from forestry waste, from paper and cardboard industry, but also seaweed or coconut shells and so on and so forth. If they are re-engineered and reprocessed, you can obviously go back to the materials in the middle, biochar, bio-oil. Some of these bio-oil are quite good and sticky, similarly to the bitumen that is used to make roads. So if you live in a country where all the bitumen is imported, especially now where we've seen how global disruption can affect the importation of crude oil, you can actually see how substituting part of the crude oil bitumen to make roads with something that is local and that you can regenerate might be helpful. The theory behind it is quite simple. If you have a tree during the life cycle of a tree, the tree is going to collect CO2 and release O2. So what's stored inside the tree is the C part, the carbon part. So trees, they act as a carbon storage. When you chop the tree down to make a timber floor or other sort of stuff, you are spending carbon to produce that timber floor. So the idea is that some of that carbon can be discounted because it was accumulated inside the tree. And the carbon that is accumulated inside the tree during the service life of the tree itself, it's usually greater than the amount that is spent to produce timber board. You can get the waste from that tree and produce bio-oil. That's how a bio-oil comes with a negative carbon footprint, and therefore when you substitute that bio-oil for your crude oil, petroleum-based bitumen, that can become a lower carbon material. Some of the examples of roads that were built from ideas to impact, you can see some of them there. They don't look any different. You don't substitute 100% of the petroleum-based bitumen, but they measured a reduction in the carbon footprint of their project up to 66%, which is quite remarkable. So in short, and just to conclude, there are several streams that you can use. Not all of them are suitable. As I said, we don't really want to just shovel waste into the road construction business, but if it's rightly selected, if it's reprocessed, if it's re-engineered, then it can be used safely and as a performance enhancer into road infrastructure. So waste is only a problem where we don't use it, when it's unused, when you leave it there and you put it into landfill. But there are solutions out there that exist, and that creates economy, that creates multiple advantages for local communities. That's it. Thank you very much.
Thank you, Professor Filippo. I think this is very insightful as well and impactful. We've been discussed a lot about recycling the waste, but we see the real example here in Australia and PNG. So let's open up the floor to have some questions. I think we have some. Please.
Hello, good morning. I just want to ask how much energy is required to convert those bio waste into road asphalt or anything. Yeah.
Well, I guess the energy depends really on the process you're using. Most of the conversion of that biomass to bio-oil and biochar comes through what's called pyrolysis or destructive distillation. So whether it's a slow pyrolysis, fast pyrolysis, the energy can be different. But there are some certificates around the world, in Australia as well, which are called environmental product declarations, which is basically a table that has followed international standards that tells you exactly how much energy is spent to produce 1 ton of that particular material. Now, the answer to your question cannot be unique, because if it's coconut that we are pyrolyzing, or if it's rubber, or if it's plastic, the yield changes. So whatever you're getting in terms of oil might be 20%, might be 60%, depending on what you are pyrolyzing or distillating. Okay? So there is not a single energy value to it, but there are several certificates for different products that can tell you exactly how much was emitted or how much energy was spent to produce 1 ton of that particular material. But usually the calculation gives you a lower or even sometimes a negative value compared to the standard petroleum-based materials.
Okay. Is it all right? 2 more questions. Okay. So because I already saw a process before, they're using bio waste for fuel at the same time for another material. So is that possible for this one? And then
No.
No. Okay.
So when you do pyrolysis of anything that is biomass, you get a very heavy crude oil similar type of substance, and that's what we use. It's a pitch, bio pitch, however you want to call it. It's very heavy and dense. You can use it straight away. If you want to reuse it for biofuels, for instance, that's too heavy. You need to refine it further and just extract the very volatile part of it. In fact, what you use as a biofuel is not dark and black. It's very light and yellow in color because you have eliminated all the dark, peach, heavy fraction of that oil. So you need to go through several stages of further refining to get the more elite type of fuel-related products.
Okay, last question. Because I'm just curious about the bio waste. When you convert it for the roads, do you still need to mix it with another material, or is it just the all bio waste?
No, you can't build a road with 100% bio oil. Usually the replacement is between 10 to 30%, 5 to 30%. The other part still needs to be petroleum bitumen. No problem.
Thank you so much, Professor Filippo.
Thank you.
Next, we welcome Dr. Hee-moon Park from Korea Institute of Civil Engineering and Building Technology, where he focuses on pavement engineering and infrastructure asset management. His presentation will introduce technical cooperation activities in Pakistan aimed at improving pavement performance and enhancing road safety through advanced engineering approaches.
Thank you for the introduction. My name is Hee-moon Park from KICT. The title that I'm going to make a presentation is Technical Cooperation for Enhancing Pavement Performance and Road Safety in Pakistan. This is not working? It's not working. Okay. Let me introduce overview of TA project. The title, thank you. The title of the TA project is Preparing Boat Transport Project, which is sponsored by ADB. The scope of this project sorry about that. Okay. I just tried this. Okay, the scope of the project is a provincial road network across the Punjab and KPK and Sindh province of the Pakistan. Okay. The objective of our project is to develop guideline for the pavement manual and the guideline enhance the traffic safety management system. Also, we introduced the advanced pavement material for helping the pavement life insurance and the transportation. We also provide capacity building, not only Pakistan, but also Republic of Korea. Okay, this is our company, so I'll just skip this one. Okay, let me talk about it, because I specialized in the pavement. I'm already focusing on the pavement issues in Pakistan. Okay, when we checking the living Pakistan pavement manual, they are using the empirical pavement design, which is very old-fashioned of the pavement design. In Korea, we are using the mechanistic empirical pavement design over about 10 years research effort. So because this is the provincial road, we don't have to use the detailed mechanistic empirical design, but at least they apply the ME design concept to actual pavement design. So we propose the simplified catalog pavement design based on mechanistic empirical pavement design concept. Also, we check the Pakistan climate and traffic condition, because it takes a lot of effort to collecting all the data in the Pakistan. So I cannot see this. So, yeah, I mean, there is a MEPDG in US. It's much flexible and very, good way to make a design in the payment. But in Korea, we have a mechanism empirical payment design program so that we just try to use that program to generate the design database. And we also try in Pakistan, there is a for example, KPK, there's mountainous area, is very cold region, and the south is Karachi is very hot. So it's totally diverse climate characterization, different climate, and also traffic characterization is totally different. So that we consider all the input data for the payment design, we have to use the mechanistic empirical payment design. The right side is payment design software we developed the Korean government. So we just tried that payment design program for the Pakistan project. Okay, this is the whole not the whole payment design process. We just try the trial payment design. For example, one is the conventional as per payment design. The other one is the payment as per payment with the WBM layer, which is a water bound macadam layer. Okay, so we generate all the design using our program and collecting the using that database, we doing the statistic analysis process to develop the catalog payment design. Okay, and next we consider about the material testing. When we checking the aspect content in the Pakistan, it's a little bit lower than what we expected. Is for example, wearing course is the 4 point of aspect content, and which is a little bit low, so that induced the fatigue cracking. So that we check the reason is that the aggregate contents is something absorption problem. Okay. We also perform the lab testing for the asphalt mixture to evaluate the mechanical property of asphalt layers, so that we can use the database at the pavement material property in Pakistan. That data can be used to input data, pavement design and quality control criteria and pavement construction. These are the pavement material testing. What we have done, we developed the master curve of the wearing courses and base courses of Pakistan. So that data can be used to not only pavement design but also quality control of the material production. And next is in Pakistan, they are using the water-bound macadam (WBM) in the field. That is not familiar with our country, but we found that they need the in-situ quality control process. That we suggest the LFWD as a QC process that can help the uniformity and consistency of the construction process. And also, we suggest how to make a soil stabilization based on the how depending on the soil quality and soil type. And we also suggest the following way development, how to back calculating and how to use the pavement management system. These are some example of the advanced material that help to green, the eco-friendly material. Okay, I'll skip this one. We provide the capacity building program, not only the Pakistan, but also Korea for pavement and the road safety issues. Okay, thank you. Any questions?
Is it working? Okay. Very interesting. You know, the materials that you have specified, are these locally available, or is this something has to be imported? Or is there alternative for those material which is readily available in Pakistan?
You mean that the material that we tested,
No, go back. Yeah, this. Yeah, this one.
this one, left side? Yeah, actually, that is from the plastic PP or PET, and we need some refinement process that the as a mixed design. We also developed the mixed design when you using the fiber in the asphalt mixtures. And Dr. Yu is the expert at the doing a lot of research on this one. Yeah.
But is that available in the country or elsewhere? But
Yeah, yeah, you can use the waste plastic, but they need some process, you know, to make a shape. Yeah.
Okay. So, in terms of the capacity building, like you did very good work, but how do you think we should now implement it? There should be like capacity building for the NHA and for the other C&W departments, which basically deals with the roads. So, what do you suggest? How should we proceed with that?
Capacity building. Yeah, I mean, we have, and in our institute, we have a school, that graduate school, that we invite the students to the from the Pakistan or other ODA countries, that we give them the education. And we also have some ODA project in Pakistan that help the capacity building, not only the lab production, laboratory improvement, but also the education process program. Yeah.
Just one more question.
Yeah.
In terms of the cost, how do you compare it with the traditional, like, because huh?
Perhaps WBM.
Yeah, with WBM, conventional method, yeah. So maybe if you can, because in Pakistan, the biggest problem is the economy and the financing. So how much would be the percentage difference
From
from the conventional method to what you are proposing?
You mean the design?
Yeah.
That's very difficult to answer. You know, yeah, I mean there is some issues, but in Korea, for example, we have 10% or 15% of the thickness, reduction effect. So that can calculating how much budget you can reduce. Yeah, yeah.
Okay.
But it's depending on the situation. Yeah.
Can I ask a question also? Thank you. It was very useful presentation. Now we're talking about climate resilience, and same applies for pavements. Now, how do you achieve, given that Pakistan undergoes quite a frequent flooding conditions? So what kind of design or any additives that you use or modification do you carry out in our design to achieve climate resilience in the pavements? Thank you.
For example, in Korea, I mean we are recycling process is mandatory. Okay, so for our situation, recycling process of the asphalt layer material will be the first step, and second one is we has to increase the pavement life using the very the advanced material. That is the second thing. Yeah.
Perhaps waterproofing in the flooding condition, so as to retain the strength of the pavement. Any additives to make it waterproofing, etc.?
Yeah, yeah, we use the some polymer or other, for example, some hydrate lime. We add it for the water issues. You mean the water-induced cracking?
Yes,
Yeah,
exactly.
yeah, yeah. We are using the lime, yeah, process. Yeah.
Okay, I'll probably get more details from you on
Yeah,
that.
yeah.
Thank you so much. Thank you.
Thank you.
Thank you, Dr. Park. And last but not least, our final speaker is Professor Henry Caroli, CEO of Tego Digital Solutions and one of the leading contributors to the development of HDM road management framework. Mr. Henry.
Okay. Thank you. you very much. Apologies if I have to look all the time because I thought it would be working either here or there. But anyway, let's make a start. Okay, so my presentation is about the HDM5. This is the Highway Development and Management System. HDM, maybe we'll start with the history because I appreciate that not many of you may have heard of what HDM is. The work started in about 1968 by the World Bank and the TRRL, as they were known at that time, that led to the development of the highway cost model. Essentially, this is a cost-benefit analysis tool. In 1979, the first version of HDM, but note the title, Highway Design and Maintenance Standards Model, was produced. HDM3, this is third version, in 87, and then in 93, we started at the University of Birmingham, the international study, and again, name change here is Highway Development and Management Tools. So the current version, HDM4, is actually a set of tools which comprises knowledge base. These are the manuals, the software that is often used for the analysis of road investments, and of course the core models, the prediction models that determine the life of a pavement. We've heard a lot of discussions about the impact of climate and so on, but these are equations, if you wish, that can be used to predict when a pavement or a road surface will deteriorate. So essentially, the HDM model is a life cycle analysis tool. You provide your inputs. The user has to determine what type of data, what type of pavements, how much traffic, and so on. But there are programs within or models within the HDM tool that then predict how that pavement will deteriorate depending on the environment, the climate, the traffic, the pavement design that you've used, the materials, et cetera, et cetera. So you predict the road deterioration, predict the effect of roadworks, and then calculate the impact on road users in terms of vehicle operating costs, road safety impacts, time costs for cargo, etc. You specify the number of years that the analysis is to be done. Up to a maximum we recommend of 50 years, but of course there's no upper limit as such. The core outputs are the net present value, economic net present value, financial net present value as well, if you wish, internal rate of returns, and so on. So far, HDM4 is used in about 67 countries. It is, if you wish, not mandatory, but required by the multilateral development banks. If any country wishes to apply for or receive financial support, they have to use, technically said, HDM4 or equivalent. Now, of course, the equivalent is pretty difficult to find usually. So the HDM model applies at 3 different levels. There's a road network level. Here we're looking at an entire road network to determine maybe the standards, look at the budget needs over a period of time, set the performance targets for that road network, and of course assess the impact on road users. So that we call the network strategy analysis model tool. There is also the roadwork program model or programmatic analysis, where you're looking at candidate road projects, maybe over a 5-year period. What should be a road program for the next 5 years? You prioritize them within a budget constraint. So you specify your budget constraints either annually or multi-year, and it should then give you how much to expect. Now, what is HDM5? HDM5 is really the enhancement of this HDM model, and primarily incorporating resilience, climate change impacts, incorporating low volume roads, improving connections with road asset management systems, road safety benefits, modeling GHG emissions, and so on. So it is meant to be an investment platform. At the moment, HDM4 is a standalone program that does the life cycle analysis and calculates the economic benefits in terms of NPV or IRR. But the next version is intended to have much better links with road asset management systems integrated within that, so that you can help users, usually a road administration, to design a program of investments, but also to design its road maintenance operations and investment programs. So the key difference will be that HDM5 will be web-based application rather than a standalone system on your laptop or desktop. So you'd be able to access it from literally anywhere that the internet exists. Obviously, there will be user control issues. You have to log in, you have to register, you probably have to purchase a license, and so on. So finally, just to finish, where are we? Phase 1 implementation is being done by TRL, and we have 2 representatives here from TRL. I can tell you more of where things are. Phase 1 has been completed, which was the analysis reviewing existing models. Phase 2, from 2027, will be to launch the minimum viable product, or MVP, incorporating the most critical features. Phase 3 by early 28 will build on the MVP and incorporate additional features, enhancements, and then finally phase 4 will be to coordinate its use around the world. So that's it for now. What I will do is just to give credit where it belongs and show what the oversight mechanism is. ADB is part of the steering committee with the World Bank as the coordinator, and TRL, as I mentioned, as the implementing agency. Over to you.
Thank you, Henry. Now let's open the floor for questions. I think we're a bit over the schedule, but still we can have some questions, right? Yes.
Hello, sir. I'm from Korea, and my name is Jun. So that my question is with all due respect, and how many member countries can apply or adopt the HDM4 model or their own economic analysis tool?
Very good question. Originally, the HDM model was designed for developing member countries, not just ADB, of course, is worldwide, but for the developing countries. However, some developed countries, more developed economies, have applied HDM principles or models in parts. HDM5 will technically be worldwide, so any country can use it. There will be a lot of, what I didn't mention is calibration. So in order to use the HDM models in a country, you need to calibrate or adapt it to the environment of that country. So provided you've done the calibration properly, you should be able to use it in Korea or any other developed country.
Yes, sir. I think so. But in my personal experience, and then this even individual the member country can calibrate or modify the subsequent model inside of the HDM4 model. Do you think personally, I think it's very hard and very it's very. How can I say? It's a lot of subside the model inside of the HDM4 model, but how do you think about that? Individual member country can manage all the calibration or something like that?
It's calibration, not change of model. So the actual equations cannot be changed, but there are coefficients that you can calibrate to affect the behavior of the predictive capacity. So you can't actually change the way the model is structured, but you can change the calibration factors. So we can have a discussion offline on this one.
Any other questions? If not, then my question.
Sure.
I think this HDM5 now has the climate resilience feature, and I want to understand whether there are constraints in using that feature for certain developing member countries where they don't have carbon accounting or other conditions or parameters that would be required.
Yeah, there will be limitations on how the resilience factors work, but the original design is that there will be climate regional factors that are provided by default. So if you're in the Philippines, you'd have your default parameters that apply for this climate region. If you were to use it in Korea, you'd have a different set of default parameters that work in the kind of climate environment that you have. In terms of resilience, it's a question of how you design and specify your pavements or your vehicles, etc. So the calibration that I was talking about is really adapting the model to the country environment where it will be used. So it allows that kind of calibration or adaptation of the models. The issue is, being a model that should work around the world, it cannot be one that is locked. It's got to be adaptable for the different countries and environments around the world.
Okay, in case they don't have such in the country, then would there be some reference data recommended?
Yes, there will be default data, but I think the more important point that maybe you're alluding to is the capacity of a country to do its own calibration. There will have to be capacity development to support those countries to do the kind of calibration and adaptation that is needed before meaningful use of a tool like HDM5. So yes, there will be need for that capacity support.
I'm sure you have the capacity building program.
Yes, there will.
Thank you.
Thank you very much.
Thank you. So thank you all to our all speakers for sharing these valuable experiences today and the practical insights from across the region. Today's presentations highlighted a wide range of approaches for moving from policy ambitions to implementations, from digitalization and climate resilience to green projects, and transport and urban planning tools. Thank you as well to all participants for joining us today. We hope the session has provided useful ideas and examples that can support future transport initiatives across your country and the region. Thank you so much. The speakers can come up for a photo.